Hey everybody, this is Alex Merced from alexmercedcoder.com. I want to make another video. I've done videos on functional programming in JavaScript before. I just wanted to do another video that's kind of think through a little bit more on the reasons why it's good to do functional programming. And again, JavaScript is a general purpose language in the sense that you could do object-oriented programming, you could do functional programming, and oftentimes you're going to kind of have to do a little bit of both. But the idea is the principles of functional programming, the way you think about problem solving and the way you think about how you use functions can provide you a lot of benefits as far as performance, memory management, etc. So let's think about this for a moment. Okay. Um, so let's see here. So let's pretend that, like, in an object-oriented programming world, we have like an object that is me. Okay, Alex. And I have a name, Alex Merced, and an age, 35. Okay. And let's say we have a method. We have a couple methods, so we'll have birthday as a method. Birthday, which is just a function. And all this function does is just take this dot age, just increases my basically I age, and then we'll say profile function console.log this. Okay, so we have this object here with these properties. Okay, I could say, hey, Alex. First, I do alex.profile. And then I go alex.birthday. And then I go alex.profile. Okay, so this birthday function is mutating the data. And that's the thing about like object-oriented programming. You have these objects that have state that changes. So since the state changes, what the results of the functions change. Okay, so we go here, hit save. Okay, and let's see here. Let's run this program. Let me just get this out of the way. And we say node scratch 2.js. Let's take a look at the results. So first, see, I was 35, and then I was 36. Okay. So I was mutated, so that function profile, it received the same input both times, but you didn't get the same result both times. So in that case, you can never trust that a function run the exact same way multiple times will get you the same result. I'd have to go back and investigate further, like, what does my data look like? Okay, so this is where we start talking about, like, this is one aspect of what's called an impure function, because this birthday function also is impure because it has a side effect, in the sense that it's altering data external to the function. Okay, so this one has a side effect, meaning I didn't pass in age. Okay, I mutated something external to the function's state. And then this function, because of that, isn't going to have sort of consistent output because it's also referring to something that has constant, that's mutable, and that does change. Okay, so if I don't get the result that I want from profile, if something happens that I don't expect, it may not necessarily be because the function went wrong. It may be because something else changed the data, so that my data got mutated somewhere. And from a bug hunting point of view, this increases the realm of possibilities of where I have to look for the information. On top of that, if you think about it from like a fundamental memory standpoint, is that you're going to end up making a lot more use of the heap because the data is not like conveniently stored in the function. So in that case, and it might get passed to another function, so that means this data has to kind of exist on the heap, which means more garbage collection, which affects performance. Okay. So basically, let's see how we would do this kind of in a more functional way. Okay. So I might still have an object with my information, so we'll call this Alex record, because usually what you would call like an immutable object is a record. So if you ever use like the immutable library in JavaScript, you can create a record. If you ever use the OCaml programming language, it's called a record. It's essentially the same thing as an object in the sense that it's key and value pairs, except you just don't change it. So it'd still be name Alex Merced. Name Alex Merced, age 35. Okay. And then what we'll do is I define these functions separately. So I'll say const birthday Okay, and what this does, it takes a record. Okay, and then what it's going to return is a new object. So it's not returning an altered version of the object. It's returning a new object. Except now, the age equals the record.age plus 1. Okay. So in that case, the result, basically you're still getting the same object. You're getting the same modification, but the original isn't changed. Okay. And then const profile. Okay. Gets passed a record as well. And we'll just console.log the record. Okay, so now if I did the same thing, if I said, hey, console.log, or if I said profile, Alex record, okay, birthday, Alex record, and then profile, Alex record. Okay, now let's take a look at the results here. Okay, I get the same object twice, but I thought I had a birthday, so why didn't that go up? Because birthday doesn't modify the object. Birthday returns a new object. And every single time I give it that same object, it's always going to give me the same result because the object never changes. So I never have to, long as I'm getting the same input, I'm always going to get the same output. It's predictable. So if I don't get the result that I expected, it's probably maybe because I gave it a separate object. And if I want a different result, I need to give it a different record. So in that case, to get the result kind of like before where I aged a year, instead of what I'd be doing is passing the result of birthday, oops, Control Z, passing the result of birthday and passing it to profile. Okay, so getting the result I want is the sum of uses of the function. So I can say, okay, Alex had a birthday. Starting from 35, if he had one birthday, I should have now a version that says 36. Because this function runs first, which returns, again, the record of new version of the object with the age being incremented. And profile then does that. And I can run this 1,000 times and it'll be the same result. If I do this 3 times, it'll always be the same result. Okay, and the beauty is this object, basically what happens is this, if you think about it, and I guess it goes underlying memory, basically, since all the data is moving forward via parameters, all the data is kind of nestled safely on the stack. So in that case, you never really have to allocate memory onto the heap. So you don't have to worry about garbage collection. Every time a function's done and the memory stack kind of, one function gets removed from the stack, that memory is freed up without the need for garbage collection. So in that case, you free up any sort of theoretical latency from garbage collection. Again, I'm not 100% exactly on how the underlying JavaScript engine works and how it allocates memory, but theoretically, If you wrote pure functions, everything should be technically on the stack, which again would mean less garbage collection. So in this case, if I wanted to have 2 birthdays, I don't run this function again, because again, the same function given the same information is always give me the same results. I would then have to give myself another birthday. So it'd be birthday. Birthday. So I can see here that I had a birthday, then another birthday, and then I am logging my profile, and I can see there, and I can be like, okay, well, the next time it's 37. It's kind of like the same thing. So essentially what would happen is that instead of like, let's say we're talking about your bank account, instead of loading up your bank account into an account object and then using methods to kind of modify the account object, what we would do is we would just load up a record with the current state of your bank account, pass it to a bunch of functions, and then save the end result of all those functions as the new state of your bank account in the database. And then the next time we make another transaction, we would again pull the data from the database, it would enter a record, but that original record doesn't change. The new version that gets saved to the database is the result of the sequence of functions that we've applied to it. But again, if something goes wrong here with any of these functions, I know it's because of what was given to the function, because the way the function's written, it's always going to do the same thing, only with the data that's being put in. It's a pure function. It always takes in the same input, and given the same input should always give in the same output. And the beauty of that is you can check, so you can use caching then. Okay, so caching meaning instead of having the whole function run, you can check, hey, is this the same input that I've used before? If this is the same thing, and this is what's happening in React, every time you update state, it's checking, hey, did you give me the same object again? And if you give React the same exact object, it's going to just be like, well, I've already done this before. I'm not going to do it again. Okay, because anytime you're going to have the same output, you're going to have the same result, so why do it again? You can't do that when the data is mutable, because even it's the same object, the same variable, that object may have been mutated. The data may have changed. So the always assumption is in like React that you're passing a new object that has the new state, and since it's not the same object, it's a new input, the function runs again. If it's the same object, we don't run the function again. We don't re-render your UI. But the beauty of that also saves performance, the ability to cache, the ability to say, hey, did you give me the same input again? I don't need to change the results. So going back to like the bank account situation, we can then build in tests into the function to sit there and test, like, did you give me something you've already done before? And be like, oh, you did? Then I'm not going to run this function again. So again, given the same input, we'll always give you the same output. So if the input doesn't change, there's no need to rerun the function. And there's never a reason why the function. So you can easier take advantage of caching. It's easier to debug because the issue is always the input. So in that case, you just have to keep tracking to see where did the input go wrong, versus looking in all sorts of different directions. Since direction is data is going to be unidirectional. Yeah, it's just a different way of thinking about how. So you're not thinking about this as an object. You're thinking about it as sort of data that's going into functions, and it's going into all the function it needs to get to the new end state of the data. That's a very sort of sloppily described version of functional programming. So I'm not changing the data, I'm creating new data, and I'm creating new data until I get to my endpoint. So that's that. My name is Alex Brissett from alexbrissetcode.com. I'll see you guys later.